Okay, so up until this point, we've only been able to find one measure of spread. We've only been looking at the range. What is the max minus the min? But this doesn't really give us a good idea of what most of our data looks like. So today we're going to talk about two other measures of spread. One of them is IQR, which means inter-quartile range. So whenever you see that word quartile, you should be thinking, I've seen quartiles before in my 5-number summary, so it has to do with that. And the other one we'll talk about is standard deviation. So these are the two things that I'm going to talk about today. Again, these are measures of spread, and we've already talked about how we classify the center of our data. If it's skewed or if it has an outlier, we're probably going to go with the median, whereas if our data is symmetric, we're going to go with finding the average or the mean. So the method of spread that we choose is going to depend on what method of center do we choose. So let's look at a couple of things. So I'm going to start off, I'm going to draw a box plot here. Say something like this. This is going to be a very symmetric box plot. Let's say that our numbers go from 90, 130, 140, 150 to 190. Alright, so this is a very symmetric box plot. It's pretty much perfect. And what you're doing when you're looking at the inter-quartile range is you're looking at the distance from Q1 up to Q3. How far apart are these numbers? So here we can see it goes from 130 to 150. So the IQR here would be 20 units. I don't really know what my units are measured in because I just made up some numbers. But the IQR would have a range of 20. And what that tells us is it tells us the most important part of your data, where most of your data falls, around the median. It's the middle 50% of your data. So the Q1 here is where 25% of your data is. Q3 is up to 75%. So we're looking at this range in between. That would be the middle 50%. So I made the analogy in class of it's the meat of your sandwich. So you can think of the whiskers on your box plot as your slices of bread, sandwiching the meat, the most important part. That's what you want to look at. So notice that if you're just looking at the middle 50%, you're completely ignoring any outliers you may have. So you may have outliers on the ends here. But if you're looking at just this IQR, we're not really worried about those. So IQR goes with the measure of center that also excludes outliers. So I think that when we looked at that, we saw that it was the median that ignored outliers. So whenever you're using the median to measure your center, you're also going to use the IQR. But as I said, this data here is very symmetric, so we probably wouldn't use the median for this one. We would use the mean, or the average. So mean or average, or sometimes we'll just write X bar. If we have symmetric data, anytime your data is symmetric and doesn't have any outliers, you're probably going to use the mean as your measure of center. And with that, you're going to use, I'm just going to abbreviate here, SD is standard deviations. So what does SD mean? So standard deviation has a really complicated formula. What you're basically doing is you're finding the average distance of each number in your data set. We'll say xi, because it could be the first number will be x1, the second number in your data set might be x2, so on and so forth, up to xn. You're finding the average distance of that number to your average. So you're averaging the distances to the average. So for example, I'll do a very simple data set here. if I were to average all these numbers together, it should come out and be 5. So I want to find the standard deviation here. So what you do to do that is you find how far is each number away from our average. So 1, for example, is 4 units away. 3 would be 2 units away. 5 is 0 units away. 7 is 2 units away. And 9 is 4 units away. Notice some of these things are negative and some of them are positive because some things are less than the mean and some things are more than the mean. So when we go to find the average, we usually add all these things up and divide by how many things we have. So when we go and we add these up, it comes out to 0. But that doesn't really make sense, so the average distance should be 0, because then the standard deviation will be 0, and that doesn't help us at all. So what we can do is, the problem we need to have, or the problem we need to correct, is that we have negative numbers here. So to fix that, what we do is we go through and we square all these numbers. And that'll make them positive. So we get 16, 4, 0, 4, and 16. And then we can add them up. If we add them up, we should come out to be 40. And the trick here is that normally you would think I would divide by 5. But if you're looking at just a sample of the data, you're actually going to divide by one number less than that. So we're going to divide by 4. So for this data set, we'd be looking at a standard deviation of, well, remember we squared things, we got to fix that, so it's the square root of 10. So our standard deviation here would be about 3.2, 3.1, 3.2, somewhere in there, whatever the square root of 10 comes out to be. So in class, you'll never have to compute the standard deviation by hand. I'll always give you a calculator to do this. So what you would do is you would go into Stat and Edit, type in your data like normal. So we type in 1, 3, 5, 7, 9 for this very simplistic data set that we've got here. I'll type that into L1, and then we go to Stat, Calculate, and it's the same thing we've been going to, one variable stats. So you type that in, and this S of X here, that's what tells you your standard deviation. So see, they gave us 3.1, which is about what I said, roughly. If you round up to the nearest tenth, you have exactly what I wrote down here. So we're pretty close. We'll see if we take the square root of 10, see if we were exactly right or not. See how they're the same decimal there, so we know we did it perfect. So that's the process. Again, you'll never have to do that by hand, but know how to find it on the calculator. Again, it's S of X. This symbol here is lowercase sigma. If, for example, you were looking at the entire population for a set of data, and you wanted to find the standard deviation for the entire population, you'd use lowercase sigma, whereas capital S there represents just a sample. So for example, if I took and I wanted to find the heights of all the kids in our school at Dobyns-Bennett, but I only measured the kids that were in one of my classes, that class would represent a sample. But if I measured everybody in the whole school, I could use the population standard deviation. It has to do with dividing by one less than the number versus dividing by the actual number that you have. So again, the important thing here is to note that standard deviation, you use that for your spread when you're looking at the mean, whenever your data is symmetric. And again, you just find it on the calculator, type in your numbers into Stat, and Edit, type them into L1, and then Stat, Calculate, one variable statistics, and it's S, capital S, X. We'll tell you what your numbers should be. That's what we talked about for spread. Trying to think if there's anything else that's really important. I can't really think of anything, so just know that from now on, range is no longer an acceptable measure of spread. You should be either using IQR, the inter-quartile range, or using the standard deviation, and know which one goes with which and when to use which one. So I'll write that down again. If your data is symmetric and has no outliers, you're going to use the mean as your measure of center, and as your measure of spread, you're going to use the standard deviation. Alright, if your distribution is skewed either to the right or to the left, or if it has an outlier, you're most likely going to use median for your center, and then you'll use the inter-quartile range for your measure of spread. So these two will always go together, and these two will always go together. You'll never mix and match there. So just a little bit of stuff to note. You can also find the IQR on the calculator. If you scroll down after you've typed in the one variable stats, it tells you Q3 and Q1. You just subtract there. So hope that was helpful. If you need any questions answered, just let me know.